All right, today we're going to be graphing simple rational functions, and our specific goal today is to talk about hyperbolas. And it says first, what's a rational function? It's where p of x and q of x are polynomials and they're being divided, but q of x cannot be 0 because dividing by 0 is undefined. So that is our formal definition right there for a rational function. Over here I have a little picture. If you take two cones and stack them point to point like this picture shows right here, and you take a big slice, these two right here make a hyperbola. Looks like two little parabolas there, right? So that makes a hyperbola. So we're going to talk a little bit about hyperbolas today, but I want to kind of show you where does it come from. So let's go to this first. What does a simple hyperbola look like? The simplest form is y equals 1 over x. And the best way for me to show you how to do that is to go into your calculator here. Go into y equals, clear anything out that you might have in there. And let's do y divided by x. And let's go ahead and let's look at a table. Now looking at the table, what do you notice right away when I have 0? It says error. Okay? So let's go with this table and let's use some of these values. I'm going to use -2. Let's see if I can slide this screen over. It's working out well for me. There we go. All right, so let's go ahead and jot down this table right here. So we have x and y. Let's use -2, -0.5, -1, -1. And we'll skip the error, right? Well, I'll say 0 and error. We'll just write it in there. We'll talk about that. And then we have 1, 1, we have 2.5. Oh, I'll throw this other one in here too. So 3 and then 0.33, just so we can kind of see what's going on. Okay, so now that we have that, let's graph it. So -2, -0.5, -1, -1. And I know that this one was on there too. Whoops, right there. And then we'll go over here, 1, 1. 2.5 and 3.33. So this is what is going on there. Let's look at it as a graph. There you go. So a little better understand how this is happening. So you have this curve. It's not quite going past the axis in both of these cases. So it's just barely by the axis right here. And it goes like that. And this is a hyperbola. But I wanted to show you this because you see this weird error right here. Well, let's look at what's going on in the graph here. Notice that it never touches or it never goes past the y-axis or the x-axis. And the reason why is because those are asymptotes. So in this picture, the x-axis is this asymptote right here. And when we go left, right, we call that a horizontal asymptote. So in our picture, our x-axis is a horizontal asymptote, and the y-axis would then be our up-down, so that would be our vertical asymptote. Now you're probably thinking, okay, so the x and y-axis are always asymptotes all the time. No, they're not. They're only like that because we're using that function right there. So let's talk about domain. So looking at this picture, all the x values I can use until we get to here. And suddenly I can't use 0, right? So it's all real, but x cannot be 0. And then let's talk about the range. So I can have all these y's, all these y's, all these y's, all these y's, and boom. I'll never have a point on 0 though. And then I can have all the y's going up to infinity. So these will be all real, but y cannot be equal to 0. See these two guys right here? They're symmetrical. They're symmetrical, and you probably noticed that with this chart too. And those are called branches. So those two pieces are called branches. Okay, so simplest form of hyperbola, asymptotes are there. You'll notice that there are two branches, and you'll notice that they are symmetrical. So with that being said, there's got to be an easier way to find out some of this information other than using a table and kind of like just muddling our way through it. So there's two general equations we're going to talk about. The first one we're going to talk about is y equals a over x minus h plus k. Okay, so this helps you find your vertical and your horizontal asymptote. X equals h is going to be your vertical asymptote, and y equals k is going to be your vertical or your horizontal asymptote. All right, so let's apply that to example number 1 right here. And it says graph it, show my table, and it's asking me for all this information. I'm going to go straight to the vertical asymptote. So we know for a vertical asymptote, x equals h. Well, what is h in here? Well, let's look at this a little bit. So a over x minus h. So in our picture then, that must be our h, and then plus k. So in our equation here then, that must be k. So our vertical asymptote would be x equals 1. What are we doing here? Where's this coming from? Well, what's happening here is this can never be 0, right? Basically, we're taking the bottom, we're setting it equal to 0, and we're solving. And we get 1. Okay? So you could take the bottom, set it equal to 0, solve it, and you get 1. And that's how I always end up doing my vertical asymptotes. But you can use x equals h if you would like to also. Let's talk about the horizontal asymptote right here. So I call this the hanger-oner. The guy that's just hanging out at the end with this general equation, he's going to be your horizontal asymptote. So we're going to say y equals 2. Now, let's go ahead and draw those in here. And anytime you're doing an asymptote, you're going to do dotted lines for it. And there is a reason why I put those in here. So they're going to guide us later on. So there's our asymptotes. Now it says to show the table, and this would be the next thing I would do. So x, y. Go to your calculator. You're going to change this up. And make sure you type it in right. So 3 divided by parenthesis x minus 1, close it up, and then plus 2. So make sure you type it in right. And then let's go to our table. In the table, you'll see where there's an error. And I like to make sure that's always right in the center of my table. So it's going to be 1 with the error. See if I can get this to... Nope, of course not. So let's see. 1 with the error. We've got 0, negative 1. And we have negative 2, 1. And then let's keep going. So 2, 5. And we have 3, 3.5. And then we also have 4, 3. Okay, so let's go ahead and plot that over here. So negative 2, 1, 0, negative 1. Then we have the error. We have 2, 5. We have 3, 3.5. And then we have 4, that's 3. So you should be able to see it goes something like this. So you should be getting pretty close to the asymptotes, but do not cross them. Do not cross them. Well, let's think about the domain and range. The x's can be anything, but they better not be 1. That's why there's an asymptote there. The y's can be anything, but they better not be a 2, because there's an asymptote there. So this is going to be all reals, but x can't be 1. And this is going to be all reals, but y is not going to be 2. So domain and range are hand in hand with your vertical and your horizontal asymptote. Okay, hand in hand. All right, now that you've seen example 1, and remember you can rewatch it, pause it, do whatever you need to do to understand example 1, I would like you to do example 2 on your own. So have example 2 done and ready for class. So bring that in then. Let's talk about a second general equation for hyperbolas here. And our second general equation is going to look a little bit different here. So y equals ax plus b all over cx plus d. I can tell the difference between this one and the other one because the other one had kind of a hanger-oner at the end. This one has a polynomial right on top of another polynomial, and they'll both have variables in it. So your vertical asymptote is still going to have the same idea. So cx plus d cannot equal 0. So you're going to solve that. And then your horizontal asymptote is going to be a little different. It's going to be y equals a over c. So it's going to be the coefficients right here in the front, your horizontal asymptote. So let's apply that to number 3. So on number 3, I'm going to go ahead and attack the vertical asymptote first. So if it's the denominator not equaling 0, we'll have 3x plus 3 cannot be 0. Subtract 3, so 3x cannot equal negative 3. So therefore, x cannot equal negative 1. That is going to be your vertical asymptote. So we're going to jot that down here, dot it up, dash it up. Then we have the horizontal asymptote. And the horizontal asymptote has to do with those coefficients right there in the front. So this is going to be y equals 1/3. It's kind of icky because it is a fraction, but I'm pretty sure that all of you can handle it. So right there is our horizontal asymptote. So let's talk about our table. So x and y. We'll go in here and please, please type this in correctly. I have students that type it in incorrectly all the time. Make sure you put parentheses around it, and then we can go into the table. And I like to see what's happening around the error. So you'll see the -1 error right there. -1 error. And then we've got -2 and 1.3. And then we have -3 and 0.8. Some icky numbers, but it's all right. You can handle it. 0 and -0.67. And 1 and -0.16. Ooh, and I see 2, 0, and that's kind of nice. Okay, so let's plot this. We've got -3, 1, 2, 3, and +0.8, so it's somewhere around there. We have -2, and we have 1.3, so somewhere around there. Then the error. Then we have 0 and -0.67, so somewhere around there. And we have 1 and -0.16, so somewhere around there. And then we have 2, 0. Now, if you're ever wondering, you're like, ooh, I don't know what's really going on here, you can look at your graph in your graphing calculator too. But you should be able to tell what's going on just by seeing the asymptotes, because it lies right along the asymptote like that. So let's go back to domain and range. Remember, hand in hand with vertical and horizontal asymptotes. X's can be anything, but X's can't be -1. Y's can be anything, but Y's can't be 1/3. So this is going to be all real. X can't be -1. And this is going to be all real. And Y cannot be 1/3. And that's it. So we got our table, we have our domain, range, vertical asymptote, horizontal asymptote. Notice the difference in this equation. It doesn't have a hanger-oner at the end. And by hanger-oner, I mean like that guy. So what I would like you to do for class is go ahead and try example 4 on your own and bring that, and then we'll go over it. So make sure you do both examples for class, and I and your other teachers will see you then. Have a fabulous night.